All right, welcome back. So let's go ahead and get doing some problems, okay? The first problem says, find the focus and directrix, okay? And then match the graph. I'm actually gonna say, let's just graph it, okay? All right, because that's what you should be doing anyways. You should be graphing it and then looking and seeing if your graph matches one of the ones that they give you. Okay, and they give us x squared equals -2y. Okay, so one of the ways we look, we think, okay, that's x squared, x has to be positive, y has to be negative in some sense, right? Okay, x squared has to be positive, so that means that this y, okay, -2y has to be positive, so y has to be negative. So that means it's going to face down. Or you could just look at this thing again and be like, oh yeah, that's this one. Okay, that's the x squared equals -4py case. Okay, so let's start drawing this thing. Okay, again, you know it's got to face down. That's a very ugly parabola there. Sorry about that. Still an ugly parabola, but it's not that ugly. Okay, so our focus is going to be down inside the parabola in some sense, and our directrix is up there. Okay, and we need these to be equidistant to each other. Okay, not too much craziness going on here. I'm just going to use the formula that I had on the other page. So x squared equals -4py. So -4p is -2. I'm sort of matching this equation with this equation. So p equals 1/2. Okay, so our focus is 0, -1/2, and our directrix is y equals +1/2. Okay, now there's another thing we can do where that we're going to do is we're going to find what's called the lattice rectum. Okay, the lattice rectum is a line segment through the focus parallel to the directrix. Okay, and it has what's called the focal diameter. And that's just the length of this lattice rectum. Okay, so in this case, it's just this line segment, and the length of it is the focal diameter. Okay, very easy to find actually. So we have our equation. X squared equals -2y. This is our parabola. Okay, our focus is at y equals -1/2. So that's going to give us x squared equals -2 times -1/2, or x squared equals 1. So x is going to equal ±1. So these points here, this point is 1, -1/2. This point here is -1, -1/2. Okay, So the focal diameter here is just simply 2. That's, again, the length from this -1, -1/2 to 1, 1/2. Okay? All right, let's do another problem. Give you guys a full look at it first, so you can pause it and write down anything you missed. Now let's go to the next problem. Number 18. Okay, so it's going to give us find the standard equation of the parabola with focus at 0, 4 and directrix at y equals -2. Okay, so we're going to go ahead, we're going to draw it, and then we'll see what our equation is. Okay, so first thing that I'm going to do, as usual, draw my coordinate axes. Okay, I'm going to put down my focus. My focus is 0, 4. Let's write that here. My directrix is y equals -2. Okay, already we see sort of a problem. Not a problem, but it's just something different than what we've been doing. The distance from here to here is 6, right? So sort of our vertex, okay, our vertex should be halfway between them. Okay, so that's not going to be at the origin. So it's going to start out right away. We're going to start here at this point, 0, 1. Okay, and now if we want to draw this, we're not going to draw it down this way because you don't go through the vertex, you go away from the vertex around the focus. So we know what it's sort of supposed to look like easily. Okay, so there's the parabola in some sense. There's the drawing of it. Now we got to find the equation. This has moved things. Okay, this has moved things. It's still basically, you know, an x squared equals 4p, but now instead of y, we're going to write y minus 1. Okay, now, how do we know whether to do minus or plus 1? Okay, I could go into lengthy things about transformations, but it's sort of the other way than what we're used to. Instead, what I'm going to say is just make sure your vertex is on the parabola. Okay, so is my vertex on the parabola? So I'm looking for 0, 1. Okay, if I put 0, 1 on here, I'm going to get 0 here, 0 here. Okay, so check. If I had done plus 1, it wouldn't have worked, right? Okay, so just make sure, do that double check. Okay, now what is P? Well, P is again this distance. Okay, in this case, P has to be 3. So it's the distance from the vertex to the focus and the directrix. Okay, so here P equals 3. Okay, so we end up getting x squared equals 12 y minus 1. Now, we also are actually asked to find the focal diameter. So let's do that. Let me make a little more space for myself. Okay. So let's find the length of the focal diameter. Or actually, find the focal diameter, which is length of the lattice rectum. Okay, so remember my focus is at 0, 4. So that means y equals 4. Okay. So I'm going to plug that in. X squared equals 12 times 4 minus 1 is 3. X squared equals 36. So x is plus or minus 6. So that means that these points here are 6, 4, negative 6, 4. And the length of the lattice rectum, or the focal diameter, is 12, okay, from negative 6 to 6. Notice the same thing as this. We'll see if that works out every time, okay? All right, I'll see you all in the next video.